Name of subject, internal combustion engines. Name of chapter, SI engines fuel supply system, ignition system, combustion. Name of topic, mechanical and vacuum ignition advance mechanisms. Mechanical and vacuum ignition advance mechanisms. So, dear friends, in the last video, as we already started to discuss about the ignition advance mechanism, now we come to know there is a need and the requirement of the ignition advance mechanism as the load and speed varies. So sometimes there is a need to advance the ignition timing. That's why we have to use the ignition advance mechanism in different two-wheelers engine. So generally such kind of ignition advance mechanism is very much useful in the case of carburetor, ultimately in the case of two-wheeler four-stroke engine. In various cases, such kind of engine advance mechanisms can be used for four-stroke engines of a car engine itself. So, there are two general methods which are used in modern engines to advance and retard the ignition timing automatically in relation to the engine speed and the operating conditions after the initial timing is set manually. The most of manufacturers call these methods as automatic advance mechanisms. So again, these ignition advance mechanisms are classified in two basic types. One is a mechanical, this is also called as a centrifugal advance mechanism, and the another one, that is a vacuum advance mechanism. Now one by one we will be understand this kind of a mechanism in detail. So here ignition advance mechanism is nothing but the condition when the ignition of fuel occurs earlier than the correct ignition time. So ignition of mixture takes place near the end of compression stroke if the ignition is advanced. It means the air fuel mixture will be burned too early before the end of compression stroke. So this is nothing but the ignition advance mechanisms used. So along with these basic things about the engine ignition advance mechanisms, here we will discuss about the type, and that is nothing but first one, mechanical or centrifugal ignition advance mechanism. So here we have the diagram of a mechanical or the centrifugal type of ignition advance mechanism. So why it is called the centrifugal? Because we are using the centrifugal force in the case of this particular mechanism. So before going to understand the working principle of this one, we must have to understand the different components which are present in this particular diagram. So we start with the pivot point weight. So here is one weight and another weight which is present over here. So this is the pivot point of weight. Then there is a distributor body. This body is nothing but called as a distributor body. So again the central shaft which pivot to increase the advance. So this is the central shaft. So again this particular thing is nothing but called as the heel of weight pushes here to rotate the central shaft. So there is a heel of weight which is used to push to rotate the central shaft. Now the spring which regulates the advance. So here is one spring and here is the another spring. So the centrifugal weights, two weights are present over here. Here is one weight and another weight is also present over here. So this point is nothing but called as a stop which limits advance, which may be bent into increase or decrease the total advance. And this one is nothing but called as a spring mounting post which can be bent to increase or decrease the spring tension. So this is all about the different components which are associated with this particular centrifugal type of ignition advance mechanism. So dear friends, in this case what happens, as this particular central shaft rotates, because of the centrifugal force, whatever things which is present or which is surrounding to this particular body, it will move away from the center. This is the principle of centrifugal force. Now in this case what happens, as this shaft will start to rotate with high speed, that time these two weights will move away from the center. So that time, because of the spring is there, that particular spring will be operated and these particular two weights will be moved away from the center of this particular shaft. and as that will be move away, that time the stop switch will be operate, and as the stop switch will be operate, that time again the mechanical mechanism will be forced to use, and it can able to make the advancement in the timing of the spark. So this is nothing but called as a mechanical or centrifugal ignition advance mechanism. So we have to see one video. In that video you will get more understanding. Okay, so centrifugal advance mechanism is consisting of two flyweights as we just discussed. That is nothing but called the advance weight, cam, spring and base plate. So these are the different elements. So the flyweights are carried out by the distributor drive shaft through the base plate, which is fixed to the drive shaft. So the flyweights are pivoted on the base plate and attached to the cam through the springs. So here are the two springs are present in this particular diagram. The cam is connected with the distributor drive shaft through the springs, flywheel and the base plate. When the engine speed increases, the weights move out due to the centrifugal force. As I just said, centrifugal force rotating the plate and the cam in the anti-clockwise direction. This movement affects the desired advance. This timing of the spark varies from no advance at low speed to full advance at high speed itself. So at the speed is very much low, that time this will not in work, but there will be increment in the speed of the engine, then the system will be work, and these weights will move away from the center of this particular shaft itself because of the centrifugal force. So as we just discussed, this centrifugal advance can be controlled by an engine speed. It consisting two weights and two spring. We can say this is the summary of this particular centrifugal advance mechanism. At high speed, the weights fly out, which is held by the spring, and rotating the cam, hence advancing the timing. So this is called the mechanical or centrifugal ignition advance mechanism. So we will see the another type, and that is nothing but called as the vacuum ignition advance mechanism. So the purpose is same. We have to advance the timing of the spark plug, provide the spark inside the engine cylinder, but with the help of the different way. So again here we have the diagram of the vacuum ignition advance mechanism. So basically such kind of advance mechanism is connected along with the carburetor of two-wheeler engine. So here is the carburetor. Let us consider this side which is connected to the inlet wall of the engine, and this side is open to the atmosphere, through which the amount of air will come inside the carburetor itself. Okay, so at this particular location where the wall is there, okay, so here is that particular wall, and at this particular wall there is a hose pipe which connected to one more device, and this device is nothing but called as a diaphragm operated things. So this hose pipe which is connected to the main body of the carburetor at this location, and it is connected with the help of hose pipe to this particular diaphragm. And the diaphragm is again connected for the operation of this particular base plate. Okay, and the base plate is again connected to that particular contact breaker of the spark plug. So in this case again what happen, as the amount of air will come inside the engine cylinder, as the throttle wall will be partially open or fully open, accordingly the amount of air will come inside the carburetor body. And as the, suppose if you can take the example, now this is a partial opening of the throttle valve, so less amount of air will come inside the carburetor body. That time, as per the opening of this valve, the whatever air which is present inside this particular diaphragm body itself, that will be revert sent inside the carburetor body because of the creation of the vacuum. Okay, do you understand? Please concentrate on my statement, what I am telling. As the throttle opening like partially which present in this particular diagram, as air enters from the atmosphere in the carburetor body, that time because of the creation of vacuum, the air will flow from the diaphragm to this particular hose pipe to the carburetor body, and at the same time because of the creation of vacuum it will be moving back. The diaphragm is a flexible device. So because of that particular creation of vacuum, it will be moving back, we can say, and because of the this particular diaphragm spring moving back, it is connected to one base plate, and as it will be moving in backward direction, there will be a small rotation of the base plate, and this base plate will start to rotate, which is connected to the contact breaker of the spark plug. And because of this movement, there should be some advancement. So again, the amount of air will increases as the throttle valve will get more open. Suppose the fully open, then again the vacuum creates over here. That time, if the more air comes inside the carburetor body, that time the reversing will be happen, and the things will move with very high speed. Okay, so such kind of things will happen in vacuum advanced mechanisms, which will be totally work on the vacuum creation. So again, the vacuum advance mechanism as shown in the figure, which consisting a diaphragm which automatically advance and retards the ignition timing according to the engine speed and the operating condition. That is very important. So the diaphragm forms two chambers, one of which is connected to the induction manifold and the other is open to the atmosphere. As I said you, this side is connected to the engine and this side is open to the atmosphere. So a linkage connects the diaphragm to the distributor. When the diaphragm is in its normal position, the contact breaker is held fully retarded. When the engine speed increases, the induction manifold depression is high and the diaphragm is pressed up by the atmospheric pressure. So the movement of the diaphragm moves the contact breaker in the opposite direction to rotate and thereby advancing the ignition. So a decrease in the vacuum allows the diaphragm to return back to its original setting, retarding the ignition. So this is something about the vacuum advance mechanism. So I hope you understood these particular things clearly. So now we are going to understand one video, and with the help of this video, we are able to understand this particular concept of centrifugal ignition advance mechanism and vacuum ignition advance mechanism thoroughly and clearly. So please watch the video.
Timing of the spark is normally set at idle speeds by positioning the distributor body in relation to its rotating cam. The timing is set on number 1 cylinder, and the contacts are operated in turn by each cam lobe to provide the same timing point for succeeding cylinders in the firing order. This initial setting before TDC allows time for maximum pressure in the cylinder to be developed just as the piston is descending on the power stroke. However, as engine speed increases, there is less and less time for the mixture to be ignited and for this maximum pressure to be developed. So the ignition point has to be advanced. This must occur automatically in relation to engine speed and engine load. The speed-sensitive mechanism is a centrifugal type, which is located beneath the distributor base plate and rotates with the distributor cam. As engine speed rises, the flyweights on the advanced mechanism are thrown outward by centrifugal force. Since the cam is able to pivot on the distributor shaft, the weights act against their springs and move the cam forward. Under these conditions, the quantity of mixture entering the cylinder is reduced and the air-fuel ratio is set for maximum economy on a lean setting. This type of mixture burns more slowly and therefore must be ignited earlier in the cycle to derive maximum benefit from the fuel. The load-sensitive mechanism is a vacuum advance unit which is operated by intake manifold vacuum via a port on the carburetor or the fuel injection throttle body. The port is connected by a vacuum line to a sealed chamber on one side of a spring-loaded diaphragm. A mechanical link on the other side connects the diaphragm to the distributor base plate. The base plate is movable and can be rotated in relation to the distributor body in the opposite direction to the distributor cam rotation. The port in the throttle body is above the throttle plate when the engine is idling and no vacuum can reach the advance unit. However, at light throttle openings, the vacuum port is exposed and manifold vacuum is transmitted to the sealed chamber. The diaphragm moves against the spring to rotate the base plate, and since the base plate carries the contact breaker, the contacts meet the distributor cam earlier in rotation, advancing the spark. As the throttle is opened wider, there is less vacuum effect in the manifold and consequently less vacuum advance. At wide open throttle openings, there will be no vacuum advance at all, and ignition advance will be determined solely by the speed-sensitive mechanism.
So hope you understood the things clearly with the help of the kind of video. So with the help of this video, we could understand the working principle of the centrifugal type of ignition advance mechanism and the vacuum ignition advance mechanism. So finally, we can summarize this. The centrifugal advance mechanism takes much care of speed only and not the load condition, whereas the vacuum advance mechanism is applied on the distributor. So in the design, part of the ignition advance is due to the centrifugal force and part of the vacuum produced in the intake manifold. So the combination of the two mechanisms gives the practically perfect smart timing for all driving conditions. So thank you so much for watching our today's session. Thanks a lot.